Hey guys, so here's an instructional video to help you out with one of your Mathia workspaces. It's titled Angles and Circles, Determining Central and Inscribed Angles and Circles, and that's part of your Unit 6 Mathia workspace there. Okay, so I'm going to go through examples 1 and 2. I know you can't see example 3 right now, but I'm going to kind of adjust my paper when I get there. So let's kind of get started going through these. So one of the concepts you guys are going to be learning about is something called an inscribed angle. Okay, so we're talking about basically an angle in a circle. So you guys see how I have a circle here, and I would actually be labeling this circle S. We label our circles based on whatever their center points are. So technically I'm just going to call this circle S, right, because that's what the center point is. But you guys see how I have an angle here from point A to point B to point C. That's going to be an angle inside the circle. And we know the vertex of an angle is kind of where that angle is being formed, right, or that third letter. So I can name this angle ABC or CBA, where B is that vertex, okay? Inscribed angle specifically is where the vertex of the angle is on the circle or on the circumference of the circle. And the relationship that we get is that whatever that angle is, the arc that it intercepts is double. Okay, so when we look at what we have to fill in here, it says the measurement of angle ABC. So you guys see how I have that highlighted in yellow. I look at angle ABC, and I have this highlighted in yellow too, and that angle is simply 40.2 degrees. That's a given, right? That's the information that they give us. And they're asking for the measurement. Now notice how there's just two letters here. It says AC, and there's like a little arc above it. That's asking for the measurement of arc, right? Arc AC. And arc AC is what I'm highlighting in my pencil right here. That measurement of the arc is just double whatever the inscribed angle is. So if the inscribed angle is 40.2, that means the arc has to be 80.4 degrees. Okay, so I'm going to write 80.4. Now you guys know on Mathia how they say, okay, well, what's the reason? Simply, your reason for all of this is just simply an inscribed angle. Okay, it's a property of an inscribed angle. Okay? All right, now central angles is your next type of angle that you can have in a circle. So again, I'm going to be looking at my circle here. I would also call this circle S, because, right, the center point of my circle is the letter S. But now notice how the vertex of the angle I have here, so RST, right, or TSR, that vertex of S, I'm going to, again, just kind of point to it and write, that's my vertex. Now it's the actual center point of the circle, right? Here my vertex is on the circle. Here my vertex is the center of the circle, okay? And they're actually not giving me that angle there. They're giving me the measurement of the arc. Okay, so see how I have that highlighted in the neon yellow here? And again, over here, this information is saying, okay, the measurement of arc, right, arc RT. So from point R to point T, the arc, the measurement of that arc is 30.4 degrees. And they're asking for the measurement of angle RST. So RST, right, here's my central angle. They're asking for, okay, well, what's that angle there? Now, this is different than an inscribed angle. The actual measurement of the angle for a central angle is equal to the arc that it intercepts. So if the arc is 30.4, that means the central angle is also going to be 30.4 degrees. And you can think of that vice versa as well. If they gave you the central angle, they said, hey, your central angle is 30.4. What's the measurement of the arc? Well, the arc's also going to be the exact same measurement of 30.4. Okay? And your reason for that, once again, that's just going to be central angle. Okay? All right, now our third example, example 3, okay? They're going to be giving you a diagram where you both have a central angle and an inscribed angle in the same diagram. Now, nothing's going to change based on our properties of an inscribed angle and a central angle. We're going to still take those two concepts and just apply them to the same diagram. Okay, so notice in the diagram, they're actually giving me this angle here of 24.5 degrees. Now we got to see, is this angle here, is that part of an inscribed angle or is it part of a central angle? And I tried matching up the colors in the diagram so you guys can see, right? Inscribed angle we had in green, central angle we had in pink, and I kind of did that same color coding here too. So 24.5 degrees right here, that's part of angle HST. TJ, where the vertex is on the circle. Now, since that vertex point T is on the circle, we know that's an inscribed angle, okay? And they're giving us that angle. They're telling us the measurement of angle HTJ is 24.5 degrees, okay? So now it's asking us, okay, well, if you know that inscribed angle is 24.5 degrees, what is the measurement of arc HJ? So let me find arc HJ. Here it is, right? And that's the arc that's being intercepted by that angle HTJ or JTH. So again, if I know that inscribed angle is 24.5 degrees, I know the arc that's being intercepted by is double that number. So if I do 24.5 times 2, right, and you guys can use your calculators here, 24.5 times 2, that's going to give me 49. So that means the arc here is 49 degrees, so I'll fill that in here. And our last question is, what is the measurement of angle HIJ? So again, locating those points, HIJ, notice the vertex is now the center of my circle, so that's a central angle. And I know whatever the arc is that's being intercepted by that central angle is going to be the exact same measurement. So the measurement of angle HIJ is 49 degrees. Okay, so you kind of have your two examples, guys, your inscribed angle, your central angle, and then kind of putting those two concepts together in one diagram. If you had a hard time following that, I recommend you just go through it one more time just to kind of get yourself acquainted with these properties, okay? The last page we're going to look at here, okay, we have a special case that you guys are also going to be seeing, and then a little bit of arc addition. This is pretty simple, okay? So our special case, for example 4, notice how it looks like you almost have like a quadrilateral inside of your circle here, meaning I have like 1, 2, 3, 4 sides, okay? So based on the information that they're giving us, they're telling me that angle VUT right here, this angle right there, that's 60 degrees, okay? So if I'm looking at my information, it's saying the measurement of angle VUT, that's information they're giving us, that's 60 degrees. And now they're asking us, okay, what's the measurement of arc VT? So let me find VT. Well, here's V, here's T. They're asking us, what's the measurement of this arc that's being intercepted by that angle? If I know this angle here is 60, and again, the vertex point U is on the circle, that's an inscribed angle, meaning whatever the angle is, the arc is going to be double that, or times 2. So if the angle here is 60, I know arc VT is going to be 120 degrees, okay? And then your last question, what's the measurement of angle VST? So VST intercepts that exact same arc of 120. But the vertex of the angle, right, from point V to point S to point T, that vertex, point S, is the center of the circle, meaning it's a central angle. And we know with central angles, whatever the arc that it's being intercepted by, that angle is going to be the exact same measure. So that means the measurement of angle VST is also 120 degrees, okay? Okay, our last piece here, arc addition. So again, I'm going to be looking at circle E here because that's the center of my circle. And now they're actually giving us some arc measurements. They're saying from arc A to arc B is 120 degrees, and from point B to point C is 106 degrees, and we don't know AC, okay? Couple things I just kind of want to run you guys by is the idea of a minor arc versus a major arc. So when you guys hear the word minor, you guys think smaller, right? And major, you think bigger. Minor arc, you guys would only be naming minor arcs with 2 letters, okay? And minor arc means that it has to be less than 180 degrees. And major arc, you guys can assume that it's greater than 180 degrees. So minor arc, I'm going to put above. We only use 2 letters when naming them. I'm not going to go through those with you guys. Major arc, you guys need to use 3 letters, okay, to kind of dictate which direction we'd be going in to assume that it's greater than 180 degrees, okay? So filling in our information here, so the measurement of arc AB, so notice there's only 2 letters there, so means it's going to be a minor arc or less than 180 degrees. So from point A to point B, that shortest distance is just 120, okay? Notice I'm not going from this way, from A to B, right? Because that'd be A, C, B, that's a major arc. I'm going the shortest distance between those 2 points, A, B. Now BC, same thing, that's 2 letters, it's a minor arc. I'm going to go to the shortest distance between B and C. So from B to C, that's 106 degrees. and then the measurement of arc ABC. So I'm going to follow the order of the points from point A to point B to point C, and that's simply just adding those two arcs together. So it's going to be 120 plus 106, which would give us 226 degrees.